The IDL part?
Or the IDL to VLDL?
Well, it's VLDL to IDL. So, liver packages lipids. Could be lipids it got from the breakdown of chylomicrons. Could be lipids it made, because the lipid is the most active organ in terms of lipid biosynthesis, other than adipose tissue, right? But when we think about other tissue. So, liver makes all these fatty acids, cholesterol derivatives, right? Packages them with a liver-specific protein, apolipoprotein B, into a membrane lipoprotein particle that we call VLDL, the very low density lipoprotein. What makes them very low density?
They have a lot of the fatty acids.
They have a lot of lipid, and right, lipid is lower density than water, and so they're very low density because they have the most lipid. Does that make sense? Okay, so now they travel around. As they travel around, what happens?
They get used up.
Yeah, lipids are removed for use by the tissues. And so the amount of lipid decreases. As the amount of lipid decreases, what happens? The density increases. And so they reach a state where we can tell that there has been a density change. And we can identify that as an intermediate density lipoprotein. And at that stage, the apolipoprotein B exposure on the surface of that lipoprotein particle has changed. And so the liver receptors can recognize that, bring it back in for recycling.
Or it goes to LDO?
Okay. Yeah.
So initially when it leaves the liver, it adds inactive to the receptors?
Right.
It's the conformational change that makes it so the liver will re-pick them up?
Right. So
Okay.
at VLDL, some combination of the size and the exposure of the protein, and I will admit I'm a little vague on those details, means that the liver receptors for apolipoprotein B don't bind to the VLDL. Right? The VLDL is allowed to circulate. Okay. But something changes when we get to the IDL stage, when the density has changed enough that we can identify that change and identify them as intermediate density lipoproteins, so that the liver can bind that apolipoprotein B, bring them back into the liver by endocytosis, and recycle them in the same way we described for the chylomicrons. Okay? So are we happy with that? Now, where does LDL come from?
IDL not being reabsorbed.
Yeah, IDL not being reabsorbed. If IDL stays in the circulation, and remember, there's some probability function here in the distribution of these particles, right? Not all of the blood goes through the liver in every pass. And so over time, some of the IDL particles, by probability, will end up getting shunted to other places. They stay in the circulation longer, more lipid is removed, and then they become LDL, right? So they lose more lipid, they become more dense, and now we just call them low density lipoproteins. Okay?
They lose lipid, they become less dense, right?
No, they become more dense. Lipid is less dense,
Oh, okay,
right?
yeah.
Okay, so we're straight? But still at this stage, they can be picked up by the liver. And since this story began developing, it used to be they sort of only made the distinction between VLDL and LDL, right? It was only more recently that they realized, oh, it is, right, we can identify sort of a group of lipids less dense than the LDL that are the first ones absorbed. Okay, so if you go to some, an older physiology book, probably anything more than 6 or 7 years old, they would just talk about VLDL and LDL and skip the IDL part of the story, okay? And so in the medical language, we worry about LDL and we ignore the IDL. So the receptor for these was initially called the Ldl receptor. But it ends up that same receptor for the exposed apolipoprotein B works on IDL and LDL. Okay? So are we straight? What's going on now? Okay. So the LDL receptor then brings these in, recycles the products. That's what's supposed to happen normally. Okay? Now, the problem is the liver can get saturated by the products. If the liver has too much cholesterol and too much fatty acid, one of the things it does is downregulate the LDL receptor. That is, it stops making the LDL receptor, pulls it from the membrane surface. So, if the liver already has lots of cholesterol and the LDL receptor becomes ineffective, then these continue to circulate, right? Not being pulled in by the liver. They continue to circulate. They continue to get more and more dense. So a high serum LDL, right? We're talking good cholesterol, bad cholesterol. If you have a high serum LDL, what does that indicate?
It's saturated.
Yeah. That for some reason the liver has stopped or slowed down its recycling of LDL particles. So that's why that's considered bad in the first case. It means for some reason, maybe you're taking in so much dietary lipid that that's creating a signal within the liver that it doesn't want to handle more lipid products. And so that means these are allowed to circulate in the bloodstream longer and longer and longer. Does that make sense? Was that a
But
Oh, I thought I got a over there.
if they're allowed to circulate longer and that in general is bad,
Uh-huh.
why is HDL good?
Okay, why is HDL good? No, we haven't talked about HDL. HDL is different. HDL is made in extrahepatic tissues. So HDL is made by other tissues. It is a serum lipoprotein, so it has that same general structure, right? Phospholipid monolayer, lipids in the core, characteristic apolipoprotein molecule surrounding it, right? But it is the way that extrahepatic cells, that is cells in the rest of the system, package their extra lipids to send back to the liver. And there, since it's a different apolipoprotein on the surface, it's a different receptor on the liver that receives that. So HDL is a signal that the extrahepatic tissues are effectively dealing with their extra lipid. Right? So HDL and LDL come from different sources. Does that make sense?
So Dr. Melton,
Yeah.
there's no way that the LDL can circulate long enough to become HDL?
No. And so now we have to deal with what happens to that circulating LDL if it's not properly recycled by the liver. Right? Because that's where we get the problem. Actually, this is one of those things, probably the last time I badly taught seminar, right? Because I've admitted I'm bad at it. So probably the last time I badly taught seminar, and I know it's been a long time ago because I remember the student. One of the student presentations was a paper on this, and it was the first time I'd really gotten this part of the story, which I'm sure is much better developed now, but this isn't one of those things that I do all the time. I only think about it, a week and a half, a year. What happens is that circulating LDL can begin to become decrepit, right? It gets oxidized, the proteins react with sugars in the bloodstream, and so more and more it gets labeled as something that has been in the serum too long. And so at that point, phagocytic cells, like macrophages, can begin to recognize that as something that, as cellular debris that needs to be recycled, and not as something that's properly circulating. And so those macrophages try to take in that LDL by endocytosis. They try to break it down like they would an invading cell or a piece of membrane that has broken off another cell that's died, something like that. The problem is the high lipid content of that LDL, when they bring it in and fuse it with a lysosomal vesicle and try to break that down, the high lipid content of that is something that those macrophages are not adapted to deal with. And so they can't deal with all that lipid. These vesicles begin to accumulate in the cytoplasm of these macrophages and eventually overwhelm the macrophages, and the macrophages die. And they die, and as they go through apoptosis, right, that's what happens when these things die. So as they go through apoptosis, which I know how to pronounce because I went to Dr. Ritke's seminar when she first came here, and she scolded us all about how do you say apoptosis. So now she's getting ready to leave, but I remember her seminar when she came here. So they go through a cell death cycle, but wherever they die, these lipids become deposited in what's left because they've become overwhelmed by these lipid-containing vesicles. And where do these macrophages tend to accumulate? In areas of inflammation, especially along arterial blood vessels. And where do you get areas of inflammation? Oh, gee, in the high pressure areas, just as blood is leaving the heart, right? Within what is the cardiac
Aortic?
artery? What's the artery that goes across the...
The aortic arch?
No, across the coronary artery, right? In the coronary artery, right there, right? You get these localized buildups. Where are the other places where this can happen? It can happen in the carotids,